All right, this is APAB. We are doing the Intro to BC Calc unit, and topic 3 is improper integrals. So in example 4, we're given the integral from 2 to 5 of 5 over the quantity x minus 3 dx. Notice that there would be a vertical asymptote in this function at x equals 3, and because 2 to 5 includes that window, we have to treat this as an improper integral. So essentially, we have to split this into two integrals. The integral from 2 to b, and we're going to do the limit as b approaches 3. From the left, because 2 is left of 3, right, of this 5 over x minus 3 dx, plus the limit as a approaches 3 from the right of the integral from a to 5 of 5 over x minus 3 dx. Now, the integrand itself is pretty simple. We can integrate this, most of us, pretty comfortably into a 5 natural log of the absolute value x minus 3. That's not the hard part. The hard part is splitting this apart. Now, if it's multiple choice, some of you are going to get to the point where you can comfortably look at this and just spot that it's divergent, and I'll show you why in a sec. So this is going to be the limit as b approaches 3 from the left of a 5 natural log of the absolute value of x minus 3 from 2 to b, plus the same exact thing, but now we're doing a is 3 from the right, and we're going to do the 5 natural log of the absolute value of x minus 3 from a to 5. Great. Here's the reason I said that some of you are just going to be able to spot this. This x is not in the denominator. It's in the numerator. What that means is that when I go to plug in values, I'm probably going to end up with infinite values because there's a reason that we're using limits. These things are probably approaching infinities, and they're not infinities in the denominator, they're infinities in the numerator. As soon as you start getting infinities in the numerator, you're done. It's divergent. It doesn't matter if your brain says that the infinities cancel out with each other like a positive and negative. That's just not how it works. So let's go ahead and plug in and see what happens. So the limit as b approaches 3 from the left of 5 natural log of the absolute value of b minus 3, and we'll talk about that in a sec, minus, when I plug in a 2, I get 5 natural log of the absolute value of negative 1, but it's still going to be a 1 at the end of the day, which is a 0, right? Natural log of 1 is a 0. Plus, when I plug in 5, I get 5 natural log of 2, right? The absolute value of 2, but still 2, minus the limit as a approaches 3 from the right of 5 natural log of an a minus 3. Okay, so now let's talk about what these graphs look like, right? So let's talk about this graph, right? And I'm going to talk about it up here for a sec where I have a little bit of space. A natural log graph that has an asymptote, so its domain restriction starts at 3, it's going to look like this. And because of the absolute value, essentially, it's got another version of it on the other side that makes it go the opposite direction, where, like, one unit on either side of those is going to behave the same way. What I want you to notice is both of these things are approaching an output of negative infinity. So what that means is we have a negative infinity minus a 0 plus a 5 natural log of 2 minus a negative infinity. As soon as I get infinities in the numerator, I'm done, and the answer is diverges. So there are two mistakes people make here. Number one, they don't notice the asymptote, and they just try to integrate from 5 to 2, and if they do that, they're going to get this answer without the infinities. Or number two, they get all the way down here, and then they see a negative infinity and a plus infinity and say, woohoo, they cancel, no infinities, and then they still give this answer, which is wrong. As soon as you have an infinity in a numerator, your answer is diverges. You're done. 1 over an infinity, totally fine, because that's 0. 300 million over infinity, totally fine, because that's a finite number over infinity, and it's 0. But the second the infinity lands in your numerator, you're done. The only exception to that is if you're talking about a situation where, let's say your numerator was an x squared and your denominator was an x cubed. So your numerator is an infinity squared and your denominator is an infinity cubed. That's not really how we work when we approach infinity. When we approach infinity, we only care about the degree of the numerator and denominator. So since the numerator is an x squared and the denominator would be an x cubed, well then suddenly you'd actually be looking at a 1 over x, which does go to 0 because a finite number over an infinite number goes to 0. So I should rephrase and say that if you have an infinity in a numerator and it's not divided by another infinity, because that can be a situation that we have to look at more carefully, it's definitely a divergent situation.